Using OpenStack's textbook Calculus Volume 2, we are working in Section 3.2 on techniques of integration, and these are specifically trigonometric techniques. We did a couple of problems with different powers of sine and cosine, and now we have some problem-solving strategy tips. If we have cosine to a power jx and sine to a power k of x dx, if k is odd, which is the power of sine, rewrite it by doing 1 minus the power, so that'll be an even power times sine x, and then use the trig identity, the Pythagorean identity, to rewrite that. Then we would use our u substitution where u is cosine x, du is negative sine x, and go from there. If j is odd, which is on the cosine, then you do basically the same idea, but switching the cosine with the sine. If both are even, if both powers are even, then we use that power reducing formula that I gave you. And you should have these formulas in the trig identity section of the book. So, cosine jx, sine to the kx, dx, where k is odd. We have cosine to the 8x, sine to the 5th x, dx. Since my sine has an odd power, I'm going to rewrite this as cosine to the 8x, sine to the 4x, 4th x, and then sine x dx. Because this is an even power, I can use the Pythagorean identity. We're going to write this again, cosine to the 8x of sine squared x squared sine x dx. Okay? Integral cosine to the 8x, 1 minus cosine squared x squared sine x dx. Well, if we make u equal cosine x, du equals negative sine x dx, we know we're putting a negative 1 here and here. So when we rewrite, we have negative 1 integral u to the 8 times 1 minus u squared squared du. In order to do 1 minus u squared squared, you actually have to multiply the binomial out, and you end up with 1 minus 2u squared plus u to the 4th. Distribute my u to the 8th. We have minus 1 integral u to the 8 minus 2u to the 10 plus u to the 12 du. Use your power rules now. So we have negative 1 u to the 9 over 9 minus 2u to the 11 over 11 plus u to the 13 over 13 plus c. We are going to plug cosine back in, and I have negative 1. Let's distribute that while we're going, make our lives a little bit easier. So equals negative cosine to the 9x over 9 plus 2 cosine to the 11x over 11 minus cosine to the 13x over 13 plus c. Again, remembering that a lot of times they'll pull that fraction out as a coefficient instead of putting the number under cosine. All right, same idea, except this time we're talking about k and j both being, or either one being even. We have the integral of sine to the 4th x, which we're going to rewrite as sine squared x squared dx. We're going to use the same power reducer that we used earlier. Sine squared x equals 1/2 minus 1/2 cosine 2x. So we're going to have the integral of 1/2 minus 1/2 cosine 2x squared dx. We have to expand or multiply this 1/2 minus 1/2 cosine 2x times itself. So we end up with 1/4 minus 1/2 cosine 2x, because 1/4 and 1/4 is 1/2, plus 1/4 cosine squared 2x dx. The problem here is that we have cosine squared. We don't want cosine squared. Well, the identity that we use to replace it, because it's to an even power, is for cosine 1/2 plus 1/2 of cosine 2x. And since it was a 2x here, then this is going to become a 4x. So cosine squared 2x equals 1/2 plus 1/2 cosine to the 4th x. And that's what's going to go here. Integral 1/4 minus 1/2 cosine 2x. You know what? Dx is going to go there. Dx is going to go here. Plus 1/4 integral 1/2 plus 1/2 cosine to the 4th, or sorry, cosine of 4x dx. One more breakdown. 1/4 integral dx minus 1/2 integral cosine 2x dx plus 1/4 taken out of 1/2 is 1/8 integral dx plus 1/8 integral cosine to the cosine of 4x dx. Whew. If we're doing cosine of u here, and that's 2x, then it would be 2 dx, so we need another 1/2 out front. If we're doing cosine u here, that's 4x, which would be 4 dx. It needs a 1/4 out front. So 1/4 x minus 1/4, the integral of cosine is sine 2x, plus 1/8 x plus 1/32 sine 4x plus c. You're going to put your 1/4 x and 1/8 x together, and your answer is going to be 3/8 x minus 1/4 sine 2x plus 1/32 sine 4x plus c. So next we're going to talk about products of sines and cosines of different angles, and we have some more some more identities here. If I have sine of ax and sine of bx, then the formula is like this. We're using some sum and differences. These are other things you can use to substitute. So let's do an example of this before we move on. I have the integral of sine to the 5th x, or sorry, sine of 5x times cosine 3x dx. That would be this formula. So if I have sine of 5x cosine of 3x, that means a is 5 and b is 3. So we're going to do 1/2 sine of a minus b, which is 2x, plus 1/2 sine of a plus b, which is 8x. Okay, integral. I'm going to put my 1/2 out front, sine 2x dx, plus 1/2 integral sine 8x dx. If we use u substitution, I'll have a 2 dx there and a 1/2. And over here, I'll have an 8 dx and a 1/8 out here. So this would be 1/4 negative, because sine is, or the integral of sine is negative cosine. So negative cosine 2x. This is going to be negative again, so minus 1/16 cosine 8x plus c. All right, in the next video, we will start talking about other trig functions.